Okay, this is the November 2020 multiple choice question 1 from the November 2020 physical science past paper. It says, which one of the following is the general formula for the alkanes? Well, alkanes are saturated, so we're always going to have a lot of hydrogens. Okay, we are definitely not going to have this one because it's got an oxygen. But if you don't know your general formulas, all that you can do is draw, like, for instance, a very simple alkane, like, for instance, this one, ethane. And if we have a look here, if we draw ethane and we count all of the atoms, we have got 2 carbons, and we have 1, 2, 3, 4, 5, 6 hydrogens, okay? So if you break this down, and then we will say Cn, here my n equals 2, then if you look at all of the formulas here by process of elimination, how would we get to 6? It would be 2n is going to give me 4, and then we have to add 2 to get to 6. So to me, if you can't remember your general formulas, which you should, just draw an alkane and then count your hydrogens, and by a process of elimination, see which one of the formulas they fit. Obviously, you know that we're not going to have the oxygen, so you've got rid of that answer already. Now, the next question says, what is the empirical formula of hexanoic acid? So first you have to know what hexanoic acid is. So you're going to draw 1, 2, 3, 4, 5, 6. Of course, if you know your general formulas, this is not necessary. Okay, but if you don't, draw your hexanoic acid. And now I'm going to cheat and only draw the sticks and not the hydrogens. Okay. So if we count, I've got 1, 2, 3, 4, 5, 6 carbons. So I've got 6 carbons. Okay. How many hydrogens have I got? It'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And this one on the end here makes me have 12 hydrogens. And then I've got this oxygen and this oxygen. So I've got 2 oxygens. Now this is the molecular formula, but it did not ask me for the molecular formula. It asked me for the empirical formula, which is the simplest whole number ratio. So if you look at this formula here, if there's 6 carbons, 12 hydrogens, and 2 oxygens, if you divide by 2, you'll get C3H6O. And then you just look through the answers here, and C3H6O is this answer, D. 1.3 says, which one is the correct structural formula for methyl ethanoate? So methyl ethanoate is obviously an ester, and we're going to have 1 carbon on this side and 2 carbons on that side, because the meth is 1 carbon, the eth is 2 carbons. But how do you know which side they go on? If you look at the OH, the OH part comes from the carboxylic acid. So you need to look for the carbon that is double bonded to the oxygen. The carboxylic acid gives you the carbon double bonded to the oxygen. So you look for something that's got 2 carbons that is double bonded to the oxygen. So if we look over here, there's actually 1, 2, 3 carbons before we get to the double bond in the oxygen. So this is just not okay, because it's actually carboxylic acid. That one is not even an ester. So here we have 2 carbons. In B, we've got 2 carbons, but they're directly bonded to the oxygen. So if we come over here to C, here's carbon 1, here's carbon 2, here's my double bond over here. So this looks good. And then I must check, I only must have 1 carbon on the other side. So this one is correct. And this one on the end, this one has got 1 carbon and 2 carbons, which we were looking for. But this one is ethyl methanoate, and it comes from methanoic acid, because the carbon with a double bond, this carbon over here, came from the carboxylic acid, so it can't be that one. Okay, is this the correct question? Are we 1, 2, 3, 4? Yes, question 1.4. Zinc granules react as follows with excess hydrochloric acid solution. So this is zinc metal plus hydrochloric acid gives you zinc chloride and hydrogen gas. Which one of the following initial combinations of volume and concentration of hydrochloric acid will result in the highest initial reaction rate for the same mass of zinc granules used? Assume that the zinc granules are completely covered in all cases. So if the zinc granules are completely covered in all cases, the volume of the acid should not be concerning us at all, okay? Because the volume of the zinc is not going to make any difference. What will make a difference is the concentration. So we should look for something with the highest concentration. And this one with the highest concentration, this is the highest concentration in the table. So the answer is B. The volume is not making a difference to reaction rate. The only thing that makes a difference is the concentration of hydrochloric acid, because that means there are more protons available to cover the surface of the thing that is reacting. And then we need to go to 1.5. What is the role of a catalyst in a chemical reaction? The catalyst does nothing for the yield. It does do something for the activation energy, but a positive catalyst should decrease the activation energy, so it's not this one. It is to increase the heat of reaction. No, the heat of reaction has to do with the reactants in the process, got nothing to do with the catalysts. The only thing we use it for is to increase the rate of reaction. Now it says, consider the equilibrium represented by the balanced equation below. And there's the chromate ion and some protons going to the dichromate ion and some water. But what is interesting us is over here, it says delta H is less than 0. That means this reaction is exothermic. Okay, so it says to you, which one of the following changes to the equilibrium will favor the forward reaction? So if the forward reaction is exothermic, it is favored by a decrease in temperature, because according to Le Chatelier's principle, that man, however you say his name, according to his principle, the reaction, the equilibrium will compensate for whatever change you're making. So if you decrease the temperature, the reaction will be favored that increases the temperature, which is in this case is the forward reaction. So we know it's going to be either A or B. These other two are immediately out. So now we have to look at pH. So if we increase pH, we are going to add hydroxide ions. And if we decrease pH, we are going to add protons. Okay, so if we have a look at the reaction, we have protons on the left-hand side here. So if we add more protons, okay, if we add more protons, we will want the equilibrium to get rid of this change we made. So it will want to remove protons, and the only way it can remove protons is by favoring the forward reaction. So it will be a decrease in pH and a decrease in temperature will both favor the forward reaction. So the answer is B. Okay, this one is about conjugate acids and conjugate bases. So remember, if you are finding a conjugate acid or a conjugate base, the only thing that you have to do is you have to either add a proton or subtract a proton. So immediately you look at this question. This one is out because it is not HPO4 2 minus with a plus an H or a minus a H, okay? And it's not H3PO4 phosphoric acid because that would be adding 2 protons. So now if you are looking for the conjugate base, okay, that means this must be acting as the acid. And what is an acid? An acid is a proton donor. So how will this donate a proton? We will have HPO4 2 minus, okay, going to a proton. And what happens? Reactants on the left must equal products on the right. What are we left with? We are left with PO4 3 minus if we take the proton off that polyatomic ion. So the answer to 1.7 is this one over here, B. This is the conjugate base, because here is my acid which donated the proton, and here is my conjugate base. This HPO4 2 minus is the conjugate acid of that ion. Okay, now this 1.8 says, which one of the following reactions will proceed spontaneously under standard conditions? So obviously now this is a redox question, and to answer the redox question, if you want to know if it's going to proceed spontaneously, you have to come down here and have a look at these reactions and use this formula that says the E theta of the cell is the reduction potential minus the oxidation potential. So all of these reactions can be broken down into a reduction reaction and an oxidation reaction. So you have to go to the table, and obviously in this case, here is the one reaction for the hydrogen and the protons. So if you've got your table handy, you can look at your table as well. And then somewhere here is our friend nickel. Here is our friend nickel. So now the nickel ion, what is going here? Here is the nickel ion going to the nickel metal. So this is the reduction reaction, and it has a negative value, okay? And then this one here is the oxidation reaction. The value is 0, okay? So the E theta is reduction minus oxidation. So then I have negative 0,27 minus 0. My reduction potential here is going to be negative 0,27. It will not happen. Then if we go to the next one, if we look for bromine going to the bromide ion, okay, this is my reduction reaction. Can you see it's the forward reaction? So that is 1,07. That's my reduction reaction, okay, the bromine going to the bromide ion. But then the other reaction is my oxidation reaction, okay, the chloride ion and the chlorine. And if we have a look up top here, this one actually has a more positive value. So according to this is the reduction, and then now we need to subtract the oxidation. So that now we are going to subtract 1,07 minus 1,36. Can you see that is going to give you a negative answer as well? This is not going to happen. Then if we go to the next one, it says Fe3 plus to Fe2 plus. If we go to the table, here is Fe3 plus going to Fe2 plus. That is my reduction reaction. So this one is plus 0,77. And then my oxidation reaction is the iodine and the iodide. If we go to the table, here it's this reaction over here, but obviously the reverse reaction. So then we're going to say 0,77 minus 0,54, because it's always reduction minus oxidation. This one is going to give you a positive value. So at the moment it looks like this should occur. Let's just check with the last one. If we go to the last one, we've got Cu plus going to Cu2 plus. This is not a common reaction, okay? But if we have a look here, here's the reaction in the table. This one is actually an oxidation reaction, okay? So we got to hope the other one is a reduction reaction. I've got Pb2 plus going to Pb, lead 2 plus ion going to lead. This one is indeed the reduction reaction. So my reduction reaction is going to be minus 0,13, and then we are going to subtract the oxidation reaction, minus 0,16, and as you can see, that's going to give you a negative value as well. So the answer is very definitely C, because according to the table, that is the only one that gives you a positive E theta cell. It's a bit of a long question to sit through in the multiple choice, but you always have to think in the multiple choice. Okay, now here we have electrochemistry, and this we know because there is a cell in it. This has to be electrolysis, where we use a battery to induce a chemical change, electrical to chemical. So what is the most important thing here? This is the positive side of the battery. This is the negative side of the battery. So the negative side of the battery will always be the cathode, okay? And the cathode always increases in mass when we are doing purification. And this one is the anode, and it will decrease in mass. Okay, so the cathode reduction occurs at the cathode here. And so we have the ions in solution going to the solid. So at the cathode, it'll be Cu2 plus. Remember, reduction is gain of electrons, gaining electrons going to copper metal. Now it says to you, which one of the graphs represents the change in mass of electrodes P and Q during the purification process? So now if P is the cathode, because it's connected to the negative terminal, it is definitely going to increase in mass. So we have to look at the graph where P starts low and gets bigger. So if you look over here and over here, P is starting big and getting smaller. Can you see this is a downward graph? So these two are clearly wrong, okay, because the cathode has to get bigger. Now we're left with A and C. So what is the difference between A and C? In both of them, the Q is going to nothing. But if you look in C, if you look at Q and P, they're more or less level, okay? That means that the amount of matter that was in Q was transferred to the amount of matter in P. But the fact is, the question says that this is impure. So if this is impure, there's no ways you're going to get 100% out the other side, because all the impurities are going to fall off here and become sludge at the bottom of the electrolytic cell. So the answer has to be A, because the mass of P is increasing and the mass of Q is decreasing, but P never ever goes up to what Q had a mass at the beginning, because all of the impurities are going to have ended up in the electrolyte solution. And that just leaves us with the fertilizer question, which is now out the curriculum. So I assume you're going to stop watching, but if you don't stop watching, it says, what is eutrophication in water caused by? It says eutrophication in water is caused by. So if you look in the exam guidelines, it says define eutrophication as the process by which an ecosystem becomes enriched with inorganic plant nutrients, which results in excessive plant growth. So the causation is the increase in plant nutrients, which then goes to the algal bloom, which then goes to the depletion of oxygen. But the question asks you, what is causing it? It is caused at its root cause by increasing the amount of plant nutrients in the water, usually from runoff from fertilizers. And that is the end of 2020.